Welcome to Computer Vision Stream. I'm your host Anton. We continue with Deepstream pipeline sample applications. Today we will see Deepstream test3. It's built on top of Deepstream test1 that you can check out in this video. But they have multiple additional features, such as multiple sources in the pipeline. You write the code bean to accept TSP or file input, and that will create automatically decoder and send frames to NVIDIA configuration for batch utilization and extraction of stream metadata from batched buffer. Let's see implementation of this test3 pipeline and how we can improve it into more Python code. So here from the start we can see the difference is more important for more complicated pipelines, and it is twofold in terms of lines of code. And we will see the readability difference as well. So here what we have a couple of arguments that are being parsed. Let's take a look at the code of creation of pipeline in Deepstream sample application. So here we create pipeline, and we start from creating elements, in this case string max. Then for all the sources that we have, we will try to parse them and to check if it should be some additional parameters, and we will call the function create source bin. Create source bin will be responsible for creating the URI source bin or URI decode bin with a specific parameter depending on the TSP or file source. For file source, we would like to run file in the loop. And also, we will need to know some features about Deepstream, how these sources should be dynamically linked to our Deepstream8, and that we will have to add additional callbacks. And when the decode bin will be added inside of your decode bin, we will also need to call additional callback. Here, it's very good if you try to build complex dynamic pipelines. If you want to learn more about Deepstream or you make low-level development, but for the majority pipelines that I have seen in production, especially at the beginning of building of your product, it's better to keep things simpler, and we will see how to do it with GSP Parse Launcher. Next, after we create source element, we will create a bunch of queue elements, and right now we don't know in which position in the pipeline we will use them. Then we will create primary and secondary inference and stream tiler to combine multiple images from different streams for the output to see all the streams at the same time. And we will create the output of fake sync if we chose no display parameter. But you see, it might be a little difficult to read. You will need to spend some time to understand what will be the whole pipeline. And then we will be setting some parameters, and we start adding elements to the pipeline. And also in the linking, either we will print the graph of the pipeline, or we will need to be very careful to understand, okay, which element we should link with another element. So in comparison, here we have the whole pipeline in one string. Here we have our pipeline string. We have our sources that we create in these 10 lines of code. So we have the URI source bin, if it was a file, and otherwise we will use the URI decode bin. And then, as in previous example, we will use mux sync with an index to exactly reproduce this functionality of dynamic linking that we have here. That's exactly what is happening when we try to use those callbacks to understand what will be the sync for our source element. But here, because our pipeline is static and by construction, we already know that we can use sync 0, 1, 2, 3, and Deepstream8 will accept that the pipeline will be working which could be a much simpler approach for a lot of applications, especially when those applications will be machine learning heavy. We can keep Deepstream part simple and concentrate on the business logic or to machine learning heavy part. Next, we have all our parameters inside pipeline, including types of primary inference and primary inference configuration, output processing modes, and so on. And here we also see where we place our different queues for optimization. And if you need a little bit more visibility, when you run this application, you can also consult launch pipeline with the whole pipeline, with the whole parameters initialized. Like that, you will see if some of the parameters will not be correct, or you can try to debug your pipeline with GSP launch. Let's try to run this pipeline. So we have DeepStream8 pipeline, and that will accept multiple streams as an input. Oops. Yes, it's DeepStream8 pipeline. So after some time, our entries will be generated, and we will see example that this pipeline produces exactly the same result as the pipeline generated in a bit more complicated way. So here we have two streams with detections and the probe that is working just fine. If we will go to the sample application of Deepstream test3, we will see similar results after some time. And we also can check what was the pipeline, the whole pipeline that we constructed with so you see the results are exactly the same. And in the dynamic version here we can easily extract our whole pipeline that you can possibly run with GSP launch if there are some problems. And you can always run the pipeline with GSP debug *3 to see if there are some errors, and just remember will say you exactly which element has not been linked and it will give you a correct error message. You don't have to write a lot of lines of code to check if some elements were linked or not, if they were created or not. And that will simplify your application and make the deployment easier. I hope you like this content. If you would like me to review some other sample applications, put it in the comments. You can find examples in GitHub. Subscribe to my channel, and I will see you in the next videos.